This lesson is over ratios, proportions, and percents. There is a lot of information in this lesson, however, most of it should be a review. If it is too much information for one day, then we can always break it down and we can always spend another day to go back over it. The first thing we need to talk about is a ratio. If you remember, a ratio compares two numbers by division. It can be written three different ways: as a fraction, using a colon, and then using the word to. All of those ratios would be read A to B. We need to also talk about a unit rate. A rate compares two quantities that are measured in different units, but a unit rate has a denominator of just one unit. So an example using unit rate says you are shopping for sweaters. Store A sells 2 sweaters for $60 and store B sells 3 sweaters for $90. Which store offers the best deal, and explain. We can probably use mental math on this problem if we're being honest. However, let's go ahead and talk about the unit rate and where that would come in. We're going to find a unit rate which would tell us the cost per sweater at each store. Notice per is used here in this sentence, and per is a key word that you're talking about a rate or a unit rate. So the first store, store A, sells 2 sweaters for $60. So $60 divided by 2 sweaters. And we want to find the cost of just one sweater. So we're going to divide both the numerator and the denominator, or top and bottom, by 2 so that we end up with one sweater on the bottom. So store A sells sweaters for $30 each, or $30 for one sweater. Store B sells 3 sweaters for $80. So we're going to do $80 over 3 sweaters. If we divide both the numerator and the denominator by 3, we're going to be able to figure out the price for one sweater, which in this case, 80 divided by 3 gives you $26.67, or $26.67 per sweater. So store B has a better deal because each sweater costs less. We also need to talk about converting units, so conversion factors. To convert from one unit to another, we use conversion factors, which is a ratio of two equivalent measures in different units. So some common ones would be feet and inches. 1 foot is 12 inches. Pounds and ounces, 1 pound is 16 ounces. And then yards and feet, 1 yard is 3 feet. To use a ratio to set up and figure out how to convert, it says what is 155 centimeters converted to meters. So we know that 1 meter is 100 centimeters. Our goal here is to get rid of the centimeters and to be left with meters. So we're going to multiply this by the ratio 1 meter over 100 centimeters. Go ahead and put 150 centimeters over 1 because we're multiplying fractions here and we need to multiply straight across, so it's an understood denominator of 1. Now when we multiply straight across, what's going to happen is we're going to have centimeters over centimeters, so they're going to cancel out. Then you multiply straight across and you're left with 150 meters on top over 100 because 1 times 100 is 100. Then you would do that division and get 1.55 meters. Again, notice my centimeters canceled out because one of the centimeters was in the numerator, the other centimeters was in the denominator, and centimeters divided by centimeters is just going to cancel each other out, leaving us with just meters. The Space Needle in Seattle, Washington is 605 feet tall. About how many meters tall is the building? Use the fact that 1 meter is about 3.28 feet. So in this case, we're going to take 605, the height of the Space Needle, and multiply it by 1 meter over 3.28 feet. This is actually just multiplying by 1 because 1 meter is equal or about equal to 3.28 feet. So we're not changing the height, we're just changing the unit that we're measuring the height. Again, we're going to go ahead and put 605 feet over 1. When you multiply straight across, you're going to end up with feet on top and feet on the bottom, so they're going to cancel each other out, leaving us with just meters. 605 times 1 is 605, and then 1 times 3.28 is 3.28, and we're only going to be left with meters as our units. Go ahead and divide that, and you get 184.5 meters. 184.5 meters is actually the same height as 605 feet. They're just measured in different units. Solving proportions. If you remember, a proportion is actually two ratios set equal to each other. To solve a proportion, you have to cross multiply. So a pretty basic proportion to solve says, what is the solution of the proportion? 5 over 6 equals x over 11. Cross multiplying, if you remember, means to multiply the numerator of one ratio times the denominator of the other, and do that both times, or both ways that you can, and set them equal to each other. So in this case, we would do 5 times 11, which is 55, and 6 times x, which is 6x. Set them equal to each other, and then you need to go ahead and solve the equation that you've created. In this case, we need to divide both sides by 6, which gives us 5.17 for x. This next proportion that they ask us to solve is a little bit more complicated because if you notice, in the numerators we have expressions. So it asks us, what is the solution of the proportion x minus 2 over 3 equals x plus 3 over 5. When you cross multiply here, you need to make sure that you keep the expressions x minus 2 and x plus 3 in parentheses because you need to multiply the whole numerator by the denominator. Notice that in this case, we're going to need to end up using the distributive property twice. So 5 times x minus 2 gives you 5x minus 10, and 3 times x plus 3 gives you 3x plus 9. Now we have x's, or variables, on both sides, so we need to combine my like terms. I'm going to go ahead and choose to subtract 3x from both sides. When you do that, you end up with 2x minus 10 equals 9. Then you'll need to add 10 to both sides to give you 2x equals 19. And then the last step would be to divide both sides by 2, which gives you x equals 9.5. So 9.5 is the value of x. That will make those two ratios equivalent to each other. We are going to be able to use proportions to find missing side lengths in similar figures. Similar figures are figures that have congruent or equal angles and sides that are proportional. They also have corresponding sides. Corresponding sides are what you're going to use to set up your proportion. This says in the diagram triangle ABC, and this symbol right here is read similar to. So triangle ABC is similar to triangle DEF. What is the length of DE? If you notice, they've given us all of the dimensions of triangle ABC. It's a 3, 4, 5 triangle. And then they ask us what to find the measure of DE. Corresponding sides here, and these are right triangles, so you might know this terminology, but the longest side AC would be considered the hypotenuse of the right triangle. And then it would be corresponding to the longest side or the hypotenuse of the other triangle. So AC, which measures 5, would be corresponding to DF, which is measuring 10. Honestly, you might be able to use mental math right now to figure this one out pretty easily. However, we do want to go through the process of setting up a proportion just to practice that. Your similar figures will hopefully be a little bit more difficult than this in the future. So we're trying to find the length of DE, which would be corresponding to the length of AB, which is 4. So we want to use the side lengths 4 and 5 from triangle ABC to set up a proportion with a triangle DEF because we're trying to find the length of DE, which corresponds with 4, and we know the side length 10, which corresponds with the side length 5 from triangle ABC. We don't want to use 3 from triangle ABC because we don't know the length of EF, which would be what it is corresponding to, and that's not the side that we're trying to find right now. So I set up the proportion 4 over 5, which are both the side lengths from triangle ABC, equals x over 10. Notice 4 corresponds with x, which would represent DE, and they're both on the top of the ratios, and 5 corresponds with 10, and they're both on the bottom of the ratios. That is important, that corresponding sides are in corresponding parts of your proportion that you set up. When you cross multiply here, it's pretty simple. Multiply and get 40 equals 5x, divide both sides by 5, and you get 8 equals x. Again, I would expect you to probably be able to do that in your head, but we do want to make sure that we know how to set up proportions to solve for missing side lengths of similar shapes. The next example says a student who is 5.25 feet tall is standing next to a tree. The shadow of the student is 20 feet and the shadow of the tree is 80 feet. What is the height of the tree? We know we have a student and a tree, and we know both of their shadow lengths. So with proportions, there are several different ways to set up a proportion correctly. However, there are also incorrect ways to set up a proportion. The way that I chose to set up this proportion is 5.25, which is the student's height, over 20, which is the student's shadow. So I have student's height over student's shadow for my first ratio. I'm going to need to set that equal to the tree's height over the tree's shadow. So heights are both on top and shadows are both on bottom. And I have the height and shadow of the student on the left-hand side, and I have the height and the shadow of the tree on the right-hand side of my proportion. The height of the tree is unknown, so that one's going to be x over the shadow of the tree is 80 feet. Just like all the other proportions that we've looked at, we need to go ahead and cross multiply and then divide, and you should end up with an answer of 21 feet. So the tree is 21 feet tall. The next proportion problem says 1 inch represents 12 miles on a map. That actually gives us a ratio right there, right? 1 inch to 12 miles on a map. If the distance between two buildings is 4 inches on the map, what is the actual distance? So I'm going to use the ratio from the first sentence in this problem. It says 1 inch, so I have 1, over 12 miles, so I have over 12. And it tells us that two buildings are 4 inches apart. That would correspond with the 1, so I have 1 over 12 equals 4 over x. So I have inches over miles equals, it tells us 4 inches, and my variable x is going to be measured in miles because it's asking me what is the actual distance. You would cross multiply here, and when you cross multiply here, you just get 1x equals 4 times 12 is 48. So the actual distance would be 48 miles. We can also use a proportion when we're talking about percents. You can represent A as P percent of B using the proportion A over B equals P over 100. Remember, percent means out of 100. Kind of an easier way to think about these problems is going to be using keywords is and of. If you notice, it says A is P percent of B, and we had A over B. So an easier way to think of that would be to just take is over of equals whatever the percent is over 100. So the keyword is going to go on top. Whatever number goes with is going to go on top. Whatever number goes with of is going to go on the bottom. So an example of that says what percent of 90 is 63. If we think is over of, we know that would be 63 over 90 equals the percent is what we're trying to find, so P over 100. Cross multiply and you get 6,300 equals 90p. You need to divide both sides by 90, and when you do, you get 70, so 70%. 63 is 70% of 90. The next example says what percent of 90 is 76.5? So in this case, is over of equals percent over 100. We would do 76.5 over 90 equals percent P over 100. Just like the last example, we're going to cross multiply, divide both sides by 90, and you would get 85%. The next example is a little bit different because it says 77% of what number is 77. This one might be super easy for you if you read it. But is 77, so 77 is going to go on top. It says of what number, so my variable is going to go on bottom because we don't know what number it is, equals 77 because it says 77% over 100. Hopefully this is kind of obvious to you right now, but if we need to cross multiply, we would get 7,700 equals 77x, divide both sides by 77, and you would get 100. Again, hopefully that was pretty obvious back when we first set up our proportion because we had 77 over x equals 77 over 100. So hopefully you realized, of course, x had to be 100. The last thing we need to quickly talk about is the percent equation. You can represent A as P percent of B using an equation as well. So you can say that A is equal to whatever the percent is times B. A quick reminder is that you have to change the percent to a decimal before you can multiply. And to change a percent to a decimal, you move the decimal to the left 2 places. So an example that we might want to use the percent equation on would be this. It says a sweater that normally cost $49.99 is on sale for 25% off. What is the sale price of the sweater? So in this case, we want to know what 25% is of the $49.99. So we can say, we can take the percent, 25%, times the cost, $49.99. Now, you don't want to multiply by 25 because that value is not actually 25. Remember, percent means out of 100, so we want to take that decimal, move it to the left 2 times, and the actual problem we want to multiply is 0.25 times 49.99. When you multiply that out, you get $12.50. Now, that's not how much the sweater cost, that's how much is taken off of the original price. Now we need to subtract to find the sale price. So the original price was $49.99. We're going to take off $12.50. So when we subtract those, we get $37.49. So that is how much the sweater would cost. Another way to do that, if you realize that 25% off means that you're going to be paying 75% of the cost, you could have just used 75% to find the total cost. If that didn't make sense to you, then don't do that. But I know some of you would think of it that way. So either way is fine. Either way, you can use the percent equation. Like I said, I know that's a lot of information. I think most of it should be review. However, we can take the time if we need to go back over it.